In this tutorial, I want to talk about percentiles. And recall that a percentile is going to be used when we talk about our standard normal curve. And a percentile measures the percentage of values that fall at or below a specified percentage. And we use it on the standard normal. Remember, on your standard normal, you're just looking at something that has a normal curve that has a mean equal to 0 and a standard deviation sigma equal to 1. When we talk about the percentile says if I have this value here on a standard normal, what is the z-score that corresponds to it? What is that z-score? And it always measures at or below, so it's always going to measure the left-hand side of the curve. It always measures the left-hand side of the curve. So you have to be careful when you do certain problems, because certain problems will ask you for the right-hand side. But just remember, if I want to find the right-hand side, if I want to find, for instance, this blue side over here, well, we can break the curve into the left-hand side is what we can call the bottom of the curve. So this is the bottom part of the percentage. And the blue side is called the top part of the curve. So that's the top part of it. And remember, the bottom plus the top, or all of this together, has to add up to 100%. So we can use that knowledge to figure out what are different percentages or percentiles based on what we're given. So let's go try a couple of these, and we're going to use our normal tables to do this. So in this first example, it asks us what z-score corresponds to the upper quartile of standard normal. Remember, when we're talking about the upper quartile is referred to as Q3, or we want to call it a percentile. It is the 75th percentile. So that means if I graph my curve, I draw a standard normal and I look at it, I want to find out where it's 75% of the values less than or equal to. This right here is what we call Q3, or the 75th percentile. Notice there's 75% of the values that are lower than this particular value. So I want to find the z-score. In order to do that, all we have to do now is go to my chart, my z-tables. Remember, we have negative and positive tables. And if you notice before we start, all of these tables are focused on percentiles because they're all measuring everything to the left. They never measure to the right. So if we go to problems that we do the right, we're gonna have to look at something different, and we'll do that in a second. When I look at the left, though, here's what happens. I'm gonna go in this table, and I want to find out where on this table is the value of 75%. And I'm looking inside here because the z-score is on the outside, percentage is on the inside. So when I go in here and look inside of here, I see that 75% come in here is somewhere in between these two values right here. And I'm going to round it up, and it looks like it's sitting at, if I draw a line, let's draw lines out there so we can see what they actually are. So I have a value that goes from here, and a value that goes, and a value that goes from here. And it looks like it's sitting here. So when I look at that, I see that this value here is going to be 0.7517. So that's the closest in my table that I have there. So when I go to actually find this value then, when I go to actually find that value, I'm going to give it that approximate z-score, which is 0.6, we'll say about 0.68. So the z-score here that corresponds to the 75th percentile is 0.68. So in this example, I want to try to find the top 10%. And remember, if you look at these curves and how they're shaded, look at the curve that I'm looking from on the Z table to the curve that I'm actually looking at. They're shaded on different sides. So if I want to find the top 10%, what I need to realize again that this curve is broken into two parts. There's a bottom part, and there's a top part. If I want to find the top 10%, then that means it also corresponds to the bottom 90%. And that means I need to go in my table and look for the bottom part, the bottom 90. So I need to find this area back here. That's going to correspond to a z-score here. So to go find that z-score, we go in our table. Now we're looking for the bottom 90 or 90%. And so I see when I get to 90%, I'm about right here in between, looks like these two values. Let's draw some lines out there so we can see what they are. So between those two values, I'm here. Looks like the first part is 1.2. And the other part is going to be 1.08. So it looks like it's going to be, let's call it we'll say 1.28 is the closer one. 0.08 is the close one to this. That one's closer. So we'll say this is about 1.28. So the z-score that corresponds to that is 1.28. And now the next thing we can do now that we know how to do these, let's actually do a problem with this and see how to find the actual value if you're not on a normal curve. So here we have an example that says IQ scores follow a normal distribution with a mean of 100 and a standard deviation of 15. Men's International is a nonprofit organization that accepts only people with IQ scores within the top 2%. So notice here, we are in the top 2%. That means we're at the top of the curve. What IQ scores qualify an applicant to be accepted by Mensa? So the first thing I would like to do with normal distributions are draw curves. And I know it's normal because it tells me it follows a normal distribution. Now, we're not on a standard normal anymore because our mean is not 0 and our standard deviation is 1. As a matter of fact, they told us that our mean was 100 and our standard deviation is 15. So I have a mean of 100 and a standard deviation of 15 means that this is 115, 130, and this is 145. All I do is add 15 to get out. And I can subtract 15 and go back the other way and get 85, 70, and 55 to get this way. Now, for this particular problem, I want to be in the top 2%. So I'm in the top 2. That means I'm way out here somewhere. I'm way out on this side of the curve. This is top 2%. And I want to find it this way. But remember, this curve only measures the left side. So basically, in order to find that, I need to be able to find the value that corresponds to the top 2. And if I'm looking at that, that means I'm looking at the bottom. This is the bottom 98%. So again, I need to go into my curve and find the bottom 98%. Well, right now this is my negative chart. So let me go get my positive chart. And on this chart, what I'm going to look for now is I want to look for the 98 percentile, or where is 98 going to be at. So when I look in here and I start to search, I can see that 98 is going to fall somewhere around here between these two values. So let's draw some lines so we can see what those values are. So again, I'm in between those two values. Here is the first one. And here is the other part of it. And it looks like it's closer to this. Looks like it's actually closer to this value right here. So that's 2.05. So it looks like we have a z-score. We will try to correlate this as z is equal to 2.05. Now, I need to use the z-score formula to finish this off. So to finish this off, I know that z is equal to, the z-score formula, remember, is z equals x minus mu divided by sigma. Well, I know the z that I have, I want to correspond to a particular x. And that should be some x over there. So when I do that, we're going to do 2.05 is equal to x that I don't know minus mu, and I know my mu is 100, divided by standard deviation, which is 15. And to solve this, the first thing we're going to do is we're going to multiply both sides by the standard deviation, 15. And so I'm going to multiply 15 times 2.05. I get 30.75. That equals x minus 100. Solve for x, I'm going to add 100 to both sides. And I get x is equal to 130.75. Now, that means that if a person scores somewhere out here, that's going to put them into the top 2%. So my x is equal to 130.75.